Hi everyone. Today we are solving LeetCode question number 540, single element in a sorted array. You are given a sorted array consisting of only integer where every element appears exactly twice, except for one element which appears exactly once. And we have to return the single element that appears only once. See in this array, all elements are appear uh, exactly twice like 1 1, 3 3, 4 4, 8 8. But there is exactly one element which appears only once, that is 2, and we have to return this single element. And our solution must run in big of log n time, and the space complexity will be should be big of one space. And here is the twist that makes this a medium and not an easy problem. We are not allowed to scan the array, because if we scan this array, then it will be time taking, and that means it will take big of n time, and log n should be it is smaller. And we cannot use XOR trick, or we cannot use hash map because it will use big of n space. And so if we see log n time, then what concept comes in our mind? That is binary search. But binary search on what? There is no target value to search for, right? So that is the exact puzzle we are going to crack today. The constraints are: the array length is between 1 and 10 on the power of 5, like we can see here, and every value should be between 0 to 10 to the power 5. Now let me pull out the three facts that are hiding in the this site, because these three facts are the entire solution. See the array 1 1 2 3 3 4 4 8 8. Okay, and this array 3 3 7 7 10 11 11, and the array is sorted, right? And our question represents the same, that this is a sorted array, and duplicates are adjacent. A pair is never split apart. Okay, like 1 is after 1 and 3 is after 3. So the pairs are adjacent, and every element appears exactly twice except one, that is 2 in this example. And no triplets, no quadruples. That means an element cannot appear thrice. And one thing, that problem never stated that the length is always odd, right? Because see, every element are in every element is in pair, and one element is single. So that means it is odd. Okay, the length of the array will be odd. So if we say that there are k elements in this array which are appearing twice, so the length will be 2k plus 1. Let us clear the table first. If I ask if I ask this without the complexity constraint, what our approach will be? So our first approach will be hash map counting. In hash map counting, we have to count every element and return the one with count one, right? We will traverse the whole array and put them in the hash map and count their frequency. and if the count is 1, then return the array. So the time complexity will be big O of n, and the space complexity will be also big O of n. Correct answer, but wrong on both constraints. Like we have to run in big O of log n time. Now, what will be our second approach? We can XOR everything. XOR, what is the concept of XOR? We know that A XOR A equals 0, and 0 XOR the single element is the single element. That means if we XOR A, then it will result A. So if we XOR every element or in the array, the answer will be the output. And the space complexity is 1, but the time is big O of n. And because we have to watch every element, so it will take time big O of n. Now, what will be our third approach? That is walk-in steps of 2. So we know that every there are pairs of elements, right? So we will first check index 0 against 1, like this index. Come in example 2, like we will see index 0 against index 1. This is the same, right? And check again index 2 against 3. So 7 7 is same. And we will see again index number 4, 10, and we will see index 5, that this is not equal. So the first pair that doesn't match tells us the single element is on the left of that pair, right? But time complexity is big O of n again. So this approach cannot be done here, right? Now let me draw the array with indices on the top, and please look at the indices, not the values, because the values are the distractions here. So these are our array elements, and these are indices of it: 0 1 2 3 4 5 6 7 8, and these are elements 1 1 2 3 3 4 4 8 8. Let's pretend for 10 seconds that 2 is not here. Now let's see carefully that there is a pattern of it in it. 1 1, this pattern, this pair is starting from 0th index, and this pair is starting from 2nd index, and this pair is starting from 4th index. That is, we can conclude that every pair is starting from an even index, right? So this is a pattern. But now we are putting the single element back on the its position. Now we can see that after the single element, the pairs are shifted. That means it is starting from odd indexes. See, this pair is starting from 3rd index, and 4 4 pair is starting from 5th index, that is odd. But before the single element 2, the pair is on. This the 1 1 pair is starting from 0th index, that is before the single element. So after 2, the rhythm has broken, the pattern is broken. So let me state it as a rule. So the rule is, let's say I is an even index, and ith position element of the array is equal to I plus 1 position of the array. That means the pair is still intact. So the single element is strictly to the right of I plus 1. And if it is not equal, that means The pattern has already broken at or before I. So the single element is at I or to the left of it. Let's check it on our array. Take I equal to 0, that means this element, and this element 0 and 1 element is same 1 1. That means the pair matches, these matches, and there is a pair, so the answer, our answer lies on this area. Let's say I equal to 4, that means this element and this element 3 and 4 is not equal, that means this is not a pair, and that means our answer lies on this area. Now what we will do using this information, we will find mid element of the array like we do in binary search. When we find the mid element of the array, we will see that there is a pair or not. If mid and mid plus one element is equal or not. If equal, that means our answer lies in the right of mid. And if it is not equal, that means the answer lies on the left of mid. Now we are writing the pseudocode. Before pseudocode, there is one detail we must handle before writing code. Our rule only works when I is even, but middle position inside a binary search can be add odd value also. So we do one tiny correction. If mid is odd, we step it back by one or make it even. So why step back, not forward? Because stepping back keeps mid element inside the current window. If we step forward, then we may push it out of the window. This is our pseudocode. We have defined two variables, low equal to 0 and high equal to the end of the array, right end of the array. We have defined a while loop that will break when low equal to high. We will get our middle value using this formula. You can also find middle value using low plus high by 2 formula, but that will give a integer overflow error. This prevents the integer overflow error. Now if mid is odd, that means if our mid is odd, that means we have to step back and get the even index, and after that we got the mid value. We will see that mid plus 1 is equal or not. If equal, then we will search on the right area, else we will see on the left area, and after that we will return the answer. Now I am writing the code. I have written the code. That is the whole solution. Notice how how this is the little code says compared to how much thinking went into it. Let's dry run it on the second sample input. This in this array. The length of this array is 7. The elements are 3 3 7 7 10 11 11. The middle element will be this, and the index of it is 3, that is odd. So the middle value will be corrected to uh, 2, that is second. So this second element and third element is equal, that means this is a pair, and the answer lies within the right side, and the low will be mid plus 2, that is 2 plus 2 10. So low will be 10 and high will be 11. Again the loop will resume, and the middle will be 11, that is fifth element, and fifth element is odd. That means it will be 10, 5 minus 1 4. So the mid element will be 4, and this element 10 and 11 is not equal. That is it is not a pair, and answer lies within left side, and low will be again, that means high will be set to mid, that is high will be 10 and low will be 10, and our answer will be returned after exiting the loop. There are some edge cases also that I wanted to discuss, like I have an array of single element, then the low will be 0th index and high will be 0th index, that is the same, and loop will not occur, loop will not execute, and our answer will be returned. That is one. Another edge case can be 2 comma 2 comma 3. Another edge case can be 2 comma 3 comma 3. In this, it will the low will be 2 and high will be 3, and the middle element will be 1. It will be corrected to 0, and 2 and 3 is not equal. That means low and high will be set to 0, and the answer will be returned. Now let's submit it. Now the time complexity will of this algorithm will be big O of log n, and space complexity will be big O of 1 log n, because every iteration either sets high equal to mid or low equal to mid plus 2. Both cut the live window to at most half its size. So the number of iterations is bounded by log base 2 of n. And we are not using any space, only the three integers variable like low, high, mid. Nothing grows with the input. So the space complexity will be big O of 1. Some mistakes that the beginners can make, like we cannot forget that our formula only applicable for even value of mid. So if we get an odd value of mid, then we have to make it even by stepping back, not forward. So mid equal to mid minus 1, and second mistake uh, can be writing high equal to mid minus 1 instead of high equal to mid, because in binary search algorithm, uh, even we usually write high equal to mid minus 1. So when uh, why it is so, when mid element of the array is not equal to mid plus 1 of the array, then middle index is still a candidate for holding the answer. Subtracting 1 throws the answer out of the window, and you return a neighbor instead. That's why we have to fix by putting high equal to mid. So that's it. Follow Coinslive for more DSA explanations.